Hello, everybody, and welcome back to the Azure podcast. My name is Evan Baslik. I'm joined by my fellow co-host Sajit, as well as our special guest, Vlad Joanovic. Vlad's going to talk to us about ARM, what it is, and not the hardware ARM. This will be the software ARM around Azure. But we'll get to him in a couple of minutes. Sajit, let's go through some news. There's a ton of news this week. It's build week, so like we're swimming in news.
Yeah, and we may have to kind of, do like a whole separate recap of all the build news. But we haven't had a show in the last week as well, so
Yeah,
there was some
yeah,
catch up to do. So I'm going to cover some of the stuff that was in the weeks prior to build, and then we could maybe recap the build stuff in an
yeah.
upcoming episode.
Sounds good.
So the first one is related to the web application gateway, especially the V2 version. And just to recap, what that's used for is if you have web apps, various kinds of web apps, and you want to have a unified entry point where they get redirected to the right web app based on, for example, the content of the path in the URL or something like that. You can use Web Application Gateway for that. It's kind of a load balancer for your web apps. And so it's been expensive to deploy one, and I'm happy to say they have now released the basic SKU of Web Application Gateway. It has all the basic needs that you have. The SLA is slightly lower, but if you do have a web app, it makes sense to put this on top of it now because the cost to entry is much lower. Also a similar service is the web application firewall, right? Which serves a different purpose, and that is to protect, some sort of denial of service attack or, some sort of SQL injection attacks and whatnot, or URL injection attacks that they try to do. And what that service does, it logs all the incoming requests, right? And in the past, there's a concern that it could be logging PII data as part of the request into the logs. And so now the new feature is you could specify like a pattern or a path in your logs so that if that's in the logs, it kind of gets redacted. They put kind of stars in there, so date of births or social security numbers or whatnot. If they're in the form, those things will not get captured in the logs. So that's another update. Third one.
And hey, so rolling back just because I thought we'll probably go into this at a later date, but did you see that for WAF and for firewall, which writing these rules and interpreting the results has always been a fairly challenging exercise? We released, I think it's public preview at this point, not GA, but Copilot for these that'll sort of analyze your results and analyze your rules and propose rules in natural language. I thought that was a pretty unique use of that.
And that's a Copilot in the portal you're talking about, right?
I believe it's in the portal. Yeah, I don't think it's I don't think there's an API sort of through anything else. I'm pretty sure it is in the portal. Yeah,
that's a good call out. Yep. And then the third one is very current with all the OpenAI announcements. This one was from last week that they just said that the GPT-4 Turbo with the Vision is released. This actually is kind of updated even today with the announcement of build. It just happens to coincide with that. GPT-4o for Omni, which is the latest version of the model, is also available. So now we're completely caught up with all of the latest models that are on OpenAI. They're available in Azure OpenAI. And finally, this one is actually should bring a tear to many of our eyes, especially those who have been who have been working on Azure since the early days. The cloud services, the classic cloud services, the very first Azure services that were out there, is going to be retired on the 31st of August, 2024. That's coming up. So if you haven't already moved off that, you need to get going.
Is that a tear or a smile? Because we're gonna finally be, these will finally be gone. And there's some real significant architectural limitations with these, so I have mixed feelings about it.
Yeah, I do, but they were also one of the most reliable services I experienced. They were rock solid, probably over-engineered, but rock solid. From the get-go, and so I did enjoy that part of it.
Yeah, for sure. Along the same lines. So if you didn't know this, app service environments version 1 and version 2 are built on top of cloud services. So as part of the cloud service thing, services that are leveraging cloud services, internal Microsoft services, are retiring on that timeline as well. And so, if you haven't upgraded, upgrade soon. but App Service Environment v3 has been around and GA for quite a while now. The other couple of things I want to call out, this is all about, these sort of fall in a bucket around resiliency and reliability, but Log Analytics just released a workspace replication across regions. Great if you really need your workspace to be up and you need that extra resiliency. We also have announced seamless migration of your ExpressRoute gateway SKUs from non-zonal to zonal, and then smaller SKUs to larger SKUs. Again, a great thing, because that's always been problematic because you've had to take it down to upgrade it. And then the last thing, and this is one I'm actually glad that we reversed our course on this. We were starting to head down a path of starting to charge for inter-zone traffic. It used to be free. We were going to start charging for it. We have reversed that decision, and now we're no longer going to charge for it, which is great, because that was a real anti-pattern, pushing people to not do cross-zone because the extra cost. We sort of removed that barrier. So if you're not doing it today, multi-zone, 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 and ideally even one step further in multi-region. But at a minimum, if a service has that zone redundant checkbox, just check it. Just do the migration. Just check it. It's a happier for everybody.
Yep.
So great. No, that's a good roundup. We have lots and lots of news coming over the next week or so as Bill continues to. My inbox was like this, full of Bill announcements the last couple of days. So with that being said, so let's get over to Vlad. So Vlad, let's start out. You and I have worked with each other for a long time, but if you could introduce yourself and share what you do here at Microsoft.
Yes, thank you for having me on the show. My name is Vlad Joanovic. I'm a product manager in Azure Core. I've been at Microsoft. Next month actually is going to be my 25th anniversary here at this company. So I spend a lot of time working on essentially always the server side, always the sort of IT side. Started a Windows Server, Windows XP, essentially building the management and monitoring layer within Windows called WMI. That was part of the SMS team, but then sort of moved into Windows. And I've spent basically my most of my time in this monitoring and management area. I even have sort of the box product to sort of prove it. This is the Microsoft Operations Manager sort of box. It's still in the cellophane wrapping. I was thinking of opening it for awesome. my 25th anniversary, but I don't know. And it's definitely fun to tell some of our early in career folks that, we used to sell software in a CD and it had like the system requirements here. It's like all these things that like don't exist in services.
Funny.
But I spent my first half of my career really on-prem box products, and then moved very quickly sort of into the Azure world as we started building Azure, started building really the services that our customers don't have to install and maintain them. And we could sort of build them and run them, and was initially involved with some of our management and monitoring things, since that's what I was sort of working in the on-prem days. And I was actually one of the first product managers on the app, what became now known as App Insights, and then Log Analytics a little bit. And then I was essentially embedded more deeper into Azure. I owned the compute network and storage experiences for essentially the birth of ARM. So when ARM started, we had all of the classic experiences, as you mentioned, they were going away. They were still in the old portal, but then I started working on essentially all of the ARM experiences for compute network and storage in the new portal when we were sort of transitioning between portals. And then about 6.5 years ago, probably getting close to 7, I joined essentially this Azure Resource Manager team. Being in the portal was one of the biggest clients that called ARM. I just found that sort of there's lots of sort of scenarios and discussion points and design points that portal was sort of happening a little late on. That APIs were already sort of locked and loaded, and obviously there's lots of scenarios where our customers consume our products and services through infrastructure as code and through APIs and all of those systems. So I joined the ARM team, and back then we were processing about 1 billion requests per day. Sort of, it was just maybe above above a billion
a day.
only where now it's sort of well into the sort of 50s, just below 50 billion requests per day. So they've definitely grown a lot over these last 6 years, and we've put together sort of the team now is responsible for everything in this Azure Resource Manager layer. Basically, the way that internal teams build services that customers can consume, so they can be consumed in standard ways. we started off, obviously ARM was sort of our sort of V2, if you will, from the cloud service APIs and the service management APIs that you mentioned that are finally being deprecated and sort of being sunset this August, September of 2024. But with ARM, we became sort of really a set of microservices that were sort of separately run, could be separately deployed. And it was a really sort of clear differentiation between ARM and the resource provider, but we still were able to get the consistency for customers. So customers had a consistent way to RBAC any resource across any service, whether it was a Cosmos database or whether it was a storage account or a bot framework. It could be consumed in a consistent way from APIs across from REST directly through the standard SDKs. My teams are responsible for some of our infrastructure as code investments around things like Terraform and Bicep and ARM templates. And internally, we drive some of the internal change management systems on how our teams can introduce changes and how they bake changes across the environment. But then my team also owns some of our imperative clients like CLI and PowerShell, PowerShell Core, some of our SSH investments. But in the sort of ARM core area, it's made up of the ARM core services, but also Azure Policy, Azure Resource Graph, Azure Resource Notification, services that give customers a way to query resources in a common way, but then also be able to govern these resources so that our customers can really put enforcements and make sure that resources are only created in really secure ways, and making sure that all of the governance scenarios can be met. Things like can't deploy into certain regions, that can be enforced. It can also be audited, but it can also be enforced and made true. And then the sort of final area of my team that we're sort of growing and driving is the sort of platform for the edge, and how do we connect our customers' edge environments into ARM so that even their off Azure resources can be managed as an Azure resource. So with the ability to connect servers off of Azure into ARM, so that you can now do different machine configuration scenarios against those servers. You can leverage the same sort of policy scenarios, and you can really manage your entire digital estate through this means. And you can, if you have Kubernetes clusters installed in the edge, you can connect those, and then you can consistently manage and monitor those across the environment. We really see these APIs sort of growing as ways that we want to give our customers an easy way to manage their entire digital estate, and see what's running in Azure and even other clouds, with some of our multi-cloud investments that we're public previewing now at Build that we announced
Great.
are coming. So
Great.
yeah, lots of fun things at Microsoft, and excited about where things are going with co-pilots and with ways that we're leveraging co-pilots to make things easier to configure and deploy and again run in sort of standard ways with some of our verified modules, and also some of the work that we're doing in our own co-pilot to make it easier to ask questions. Are my resources zonally resilient? Am I PCI compliant? Am I following the well-architected framework? These are the types of things that we're trying to embed into our Copilot.
And you hit on something that I think you sort of glossed over, but I think is really critical, if I heard you right, which is that ARM is sort of the layer that you interact with to get to all these other resources, right? So you really are the interface into Azure, and you're sort of defining those standards. You're not controlling what the other RPs, resource providers, do, but you are that layer in between, right? If you have to, that's what gives that consistency.
Yeah, you can think of it as a gateway. We do feel very strongly about APIs. I joke that we sort of dream an API, and we sort of think about all of the scenarios, even though we love portals and love imperative scenarios, and love to enable our customers to be fully declarative so that they can leverage infrastructure as code and sort of be able to deploy through CI/CD pipelines and automatically verify things so that they can deploy faster. But yeah, it's we've developed a system where we review every API that goes into this ARM gateway. So we have an internal API review process, sort of a design board where you can sort of bring your problem space to the board, and we help you think about the nouns, think about naming, think about the ways that you can make sure it's integrated with other scenarios, so that you're not an island. But yeah, we absolutely want to make sure it's consistent so that it can be possible to create it through infrastructure as code, and you're not creating resources through sort of post operations, which aren't addressable through some of our infrastructure code tools, and make sure that things like export work so customers can graduate from, maybe if they start in the portal, or sometimes what we refer to as click ops, and then sort of find a way to graduate. So we believe very strongly in consistency to support things like tags, to support common scopes, common resources. But then lots of different teams, like the monitor team, manage identities. All of these are then sort of standards that live across these resources. We want resources to support manage identities. We want resources for private links. We want resources to support customer keys. We have a ton of things around there. I sometimes joke that I call myself and our team the sort of API sort of police officers, where we sort of our radar detecting things just like a police staff may be doing sort of on our roads, but in terms of APIs, they can never go too fast. There's no, we write speeding tickets for going too slow or for not meeting our internal sort of SLO targets, our service level objectives. We very, very strongly look at the overall availability, number of requests coming in, how many of those are processed successfully. If they're failing, we automatically can create incidents against teams and let them know. They can have their own monitoring, but we, again, have sort of standardized monitoring that sort of runs across the board.
Give us a feel for what the process is when a new service has to be added to ARM, right? I'm sure you see this every day where there's a new Azure service, and we're talking about first-party services, let's say. What's the internal kind of process that you go through to make sure you have a smooth onboarding into ARM?
Yeah, great question. Yeah, and it's definitely very much sort of you're a new service, and it's not just new to ARM. It's really the new Azure service sort of experience, where ARM is one portion of it, but there's lots of other aspects. We run a process that has an acronym APEX. I forget what it stands for. Sort of Azure Product Experience, something like that, where we have a set of very strong sort of guidelines of what teams need to do to be successful at a private preview versus a public preview versus sort of GA, and obviously the bar goes up in terms of availability, but things starting from the original design of the service. We want services to be regionally isolated, and obviously zone resilient within regions, since Azure is experienced by customers through sort of creating resources in regions. We want those standards to be followed. But we actually have a framework within the ARM side that we've referred to sort of internally as this thing we call resource provider as a service, that makes it easy for teams to create their nouns and create the sort of shape of what those nouns look like. What are the standard properties that ARM has to support, like the location, region of a resource, tags. Obviously, the name needs to be sort of following our consistent standards because it goes through ARM. But then also things like SKUs. How does the sort of size of the resource, how does that get exposed in a common way? But then obviously RPs, the resources services, they can define what is their set of properties that need to be configured, and we help them make sure that they expose those through certain versions that are sort of very strongly versioned and have sort of strong rules for backwards compatibility and sort of breaking, whether you're preview, whether you're GA. But yeah, there's the set of teams that you work with from sort of exposing your service into ARM. But then there's obviously lots of other teams you work with: the marketing team, the documentation team, the naming team on sort of naming the service, and then all different pieces on making sure that you're monitoring your service. So you need to make sure you're integrated into all of the right monitoring logic. You get all of the great sort of automatic incident notifications through some of the monitoring integrations that we have with some of our internal systems. But yeah, we've been continually building this process. I think right now there's just over sort of 400 or so different resource providers that sort of exist, but some are very big. A resource provider like Microsoft.network, you can really think of that as almost like 20 or 25 different resource sort of services from the traffic manager services to sort of the software defined networking services to different firewall services and things. There's lots of big services within the same namespace, within the same resource. But we're continually building that process. We run different internal systems to make sure that these teams have ways that they can come to our office hours, come to sort of our different sort of internal events, and sort of meet each other, so that different services can learn from other services and learn what they've done and what they've done better. So yeah, it's something that we're continually trying to improve and trying to make it easier for teams to go from idea to service very quickly. And that's some of what we're doing for internal first party teams. We're working on sort of a way that we can make these services be something that not just internal first party Microsoft teams can do, but we're also making it so that even third parties can build services, and third parties can expose services that can be consumed from Azure. There's a good number of these that already exist, like things like Datadog and other services that we have available in the Azure portal that are supported by these other companies, but sort of are offered as resources. Oracle was another one that we just released recently at Ignite towards the end of last year. So yeah, lots of exciting things that we're doing.
That's great. Yeah, I heard Databricks is another one, right? The Databricks service is a custom service. We always look at that as a good use case.
Yeah, Databricks is a great case. Yeah, on the Databricks side, it is a bit more of a sort of a first-party service because we are considered sort of it's Microsoft supported, even though we work with Databricks very closely on it, which is a little bit different than Oracle and Datadog, where essentially you have to go to their websites to get support, and we still work with them closely.
So ARM's a global set of API. I think we know that, right? It's available. You can access it from any region. It's obviously the kind of the pillar of Azure. So I'd like to understand, how you kind of achieve that level of availability where it's too big to fail kind of thing, right? ARM, that's safe to say, right? If ARM goes down, Azure's not going to work, right? I think it's fair to say that. What are some of the kind of architectural decisions you have to take to make sure that the service is available, maybe in a degraded way, but it's always available, and Azure can continue to work?
Yeah, great question. This has been a very, very big investment across the entire team, and we've made massive improvements in this area, following a lot of the same things we recommend our customers to take around being regionally resilient, being zonally resilient within regions. ARM for a long time, ARM started off as a cloud service, leveraging sort of the service management layer of Azure, and that gave us sort of a really clear way of in a particular new region, as soon as sort of the service management layer was enabled in a region, ARM could run, and you could then start creating ARM resources in that region. That was sort of how a lot of our sort of early parts of the cloud happened. Now, as that layer is going away, we've essentially had to create sort of you can think of it as a data center version of ARM, and this data center version of ARM is sort of running on sort of a lower fabric, because ARM can't run on ARM until ARM is in the region. So we have a little bit of these sort of issues where with cloud services we sort of had that separation, but we've been doing a lot to now make ARM work. We're running on virtual machine scale sets. So virtual machine scale sets, even though we're a global service, customers interacted with us by going to management.azure.com. Those requests are traffic managed. For many years, we were using Traffic Manager to route those requests based on a performance traffic metric, where depending on where you are, so if I'm here in Seattle and I make a request to management.azure.com, that request essentially will get served by one of our West Coast data centers, West US 2 or West US 3. Sometimes it pivots between those, and then compute in those regions process that request. Even if I'm asking about a virtual machine that may be in Australia, ARM knew about a lot of these resources within those regions. As the number of regions has increased, we've essentially pivoted away from replicating a lot of resource high-level metadata from every one of these resources to just replicating the resource group local region. So now, when you make a request to ARM, it'll get still traffic managed to the local, or now we're using actually Azure Front Door to be able to do some better routing that we couldn't do in Traffic Manager, which has given us a lot of resiliency improvements and ways to sort of really be able to control traffic, really be able to look at some of the bursty traffic, some of the traffic that we're having a problem sort of processing. We can redirect that to different stamps. But now we'll always go to essentially the resource group's local region. So if you have a particular resource group, and let's say that resource group in Australia, and you have a virtual machine and a Cosmos database in those regions that's in that resource group, ARM will go to that particular ARM. So from sort of the front door sort of traffic managed ARM
It's redirected there
to the resource group ARM, and then within that resource group ARM, we look at different storage within those particular regions. So we've definitely been evolving our storage layer. We started off leveraging table storage and sort of leveraging sort of a system that we built to replicate data across table storage across all of these regions, and we've been evolving our model to leverage Cosmos database. And obviously, when we started, we were using LRS storage accounts, and then as ZRS and zone resiliency became possible, we migrated those to be ZRS configured, and then with Cosmos database, we were sort of doing the same. And now we're leveraging a Cosmos database model for fully zone resilient within the region. But then we also have ability to fail over to another region if there is an issue in that region. So a lot of times customers don't know which region they're actually going to sort of initially, that where management.azure goes to. They often think, oh, if West Europe is having an issue and my regions in Australia, maybe I won't be impacted. But if I'm in West Europe, I may be sort of being traffic managed through some of those West Europe regions, even though I'm going to eventually end up in a resource provider that's sort of regionally deployed. But yeah, we've done lots and lots of work to make sure that we can remove a region from rotation, this sort of front door region. So if there's an issue there, we very seamlessly sort of spread traffic out to the neighboring regions and be able to process traffic there. And then we still have to make a request to the regional resource when you're trying to create a database or a bot framework or a cognitive service in one of those regions. Those still require the RP there. But yeah, we're doing a lot to make sure that ARM is available, can scale with having enough capacity, having everything regionally deployed, but then being able to also grow to the demand that our customers are doing. And we're doing a lot on the sort of read plane of ARM to actually leverage the Azure Resource Graph, so that Azure Resource Graph can serve a lot of the read requests that ARM today is sometimes having to sort of send many requests to many different regions. Because if you issue a query today, for example, to say, tell me all the virtual machines I have in this subscription, you may have resource groups spread across N regions where, N is 10 or 5 or even, 20.
Right.
Today, right now, to sort of look at all of those properties of every one of those resources, ARM actually has to send requests to the compute resource provider in every one of those regions and aggregate that back. Where today, as you're doing different queries within ARG, all of that data is in ARG, Azure Resource Graph. and we can seamlessly serve those sort of high density queries back, and including sort of joins across resource providers where, you're not having to join on the client side, which was
Right.
very popular pattern when I was in the portal. We had to do quite a bit, quite a few sort of gets outside of ARM to be able to sort of pull a great view back for the customer. So you're doing a lot of client side aggregation, pulling all of the data in to then,
Right.
give you a count of how many resources are in there, rather than sort of running that on the server side, if you will, and letting
Correct.
the server side tell you the count and just sending you the count, rather than streaming it all to the client and counting. So
I remember when the portal used to just hang. Sometimes you would do it and it would just freeze, like it was doing
yes.
a lot of stuff.
Yes, yeah, the running state of a virtual machine is essentially not exposed on the list operation for the compute resource provider, and essentially you have to for each, through an array. Now with Azure Resource Graph, you can issue a query, and you can not just get the running state, but you can also get sort of the resource health, and you can get all sorts of other parameters and other sort of related data, but then maybe not sort of directly exposed on that model. And we think this model will just continue as customers are really building sort of applications on top of all of these resources, and really wanting to see their application sort of pop through this set of resources, because their application isn't a subscription and it doesn't map to a resource group. So we're working on ways to be able to sort of model that, and be able to drive and expose that. So yeah, it's so many investments that we're doing to continually do drills, improve our monitoring, improve the time that we can detect an issue to when we can sort of let a customer know that there's an issue. And then obviously once we know that there is an issue, how do we reduce the time to actually being able to fix it? Whether it's removing a region, whether it's failing over, whether it's sort of doing some of these other things that we often need to do on our side, so that a request can still process. Because
Correct. Yeah.
definitely, as we're seeing in maybe the start of Azure, we were seeing more traditional servers where you weren't often using the Azure Resource Manager layer, the control plane layer, to sort of dynamically create a lot of things. You were sort of more you were overly provisioned, sort of similar to the on-prem model, and you weren't doing things, you weren't creating and deleting resources as dynamically as now in these cloud native apps with Databricks and Snowflake and lots of other sort of AI scenarios and different machine learning scenarios. It's not uncommon now to spin up resources, spin down resources,
Right.
and that's
Kubernetes resources and
well,
whatnot. Yeah.
Kubernetes containers up, starting them, stopping them. So these applications now are depending on the control plane with a whole new level of dependency and requirements and needs, where yeah, we definitely understand that we need to make sure the Azure Resource Manager layer, not just our services, but all of the resource providers that could sort of result in these requests,
Right.
can
Respond in time. Yeah.
can be available as high as possible.
Now, you also tackled some of the performance work that you're doing, which is great. But I guess I know that the ARM API itself, I believe it's sort of rate limited for a specific customer, right? I think there is some sort of a limit, but obviously in aggregate, when you get millions of customers hitting it, you're getting a lot of traffic. What are your kind of internal sort of numbers that you shoot for in terms of requests per second? Like, what are some of your targets if you're able to share that?
Yeah, that's a great question. There's been some recent changes in this. We have been sort of leveraging an internal service called the an Azure throttling service, sort of an internal sort of standard mechanism for how throttling should be done, to make it sort of token sort of bucket enabled. We had our original throttling was sort of a really big period of time. It was sort of like an hour's worth. You had sort of a limit for sort of how many reads, how many writes within an hour period of time, and now we've shrunk that period of time, so it's much smaller time frames. And we're looking at that across many different application IDs, many different users. But users should really think of these throttling limits being subscription scope first. So a subscription gets a certain amount of quota and throttle, and it happens sort of today right now still at 2 layers. So ARM, there are sort of limits that ARM does, and when I say ARM, I really mean that sort of gateway layer. But then ARM, if it sort of doesn't get throttled by ARM, it'll actually get to the resource provider endpoint. And sometimes these resource provider endpoints have their own throttling limits, and they have their own sort of throttling sort of metrics. Sometimes they have 3-minute or 30-minute or different limits, and different for writes versus reads. So first off, it's important to understand if a customer is getting rate limited, are they getting it rate limited from ARM, or are they getting rate limited from an RP? And the best way to tell is actually through the headers that you get back. The headers that you get back on a request, if you're able to, if you own the code, if you're sort of running somebody else's code, you may not be able to see the headers coming back. But if you can see the headers coming back, you can very quickly tell if it's which limit you're crossing. Is it an ARM limit? Is an RP limit? That can help you analyze this. But right now, our sort of read limit was about I think it was 15,000 requests, 12,000 requests per hour, and then for writes it was about 1,200. We definitely have. And it essentially ended up being sort of within a region, and in some cases even per instance within a region, and obviously we don't share how many instances are in a region.
Right.
So with this move to this throttling service, we've made it regional. So now within a region, the users will get sort of a consistent set of quota coming through, because sometimes requests, especially in HTTP2, you could be kind of more stuck or sort of have a sticky connection to a particular instance, and you would sort of exhaust your quota a little bit faster there. So now you don't have to sort of spread across every instance to get sort of a little bit more. But yeah, there's lots of work that we're trying to do to look at some of these scenarios where there are a large number of callers. We do feel that one of the best practices for clients to do is to leverage our SDKs. Our SDKs have a lot of expertise sort of built within them to respect retry afters and sort of really follow some of the best practices for how often to pull. If you're using REST directly today, you're not going to benefit from some of those. So definitely encourage everyone to leverage these SDK layers. And then also for calls that you can get a higher density of data from, leverage Azure Resource Graph queries and send queries to Azure Resource Graph so that you're not having to do so many sort of individual calls. If you can sort of do one query to get all those requests, that counts as one ARM request, rather than whatever 1,000 you're doing to sort of make individual calls. If you're sort of regularly looking to see what's the running state of the VMs, what is the resource health of the VMs, these would be extremely efficient calls that you can make to Azure Resource Graph because of the density that you can get, rather than doing sort of the one-off calls that then not only get sort of ARM counted, but then get sort of CRP counted. But if there are sort of throttling questions or issues that folks have, you can definitely contact us directly, and we can introduce you to the folks working on some of these throttling improvements and make sure that we can help you understand what your calling pattern looks like today, especially if you're an ISV and you're going to be sort of leveraging that same code across a large number of customers and a large number of subscriptions. We would love to help you understand how to make that efficient, how to use templates and declarative patterns for your sort of put scenarios, and how to be as efficient as you can and balance the polling that you're having to do.
The number of calls. That's great, Vlad. Thank you. Any last thoughts in terms of what we can expect in ARM coming up? I know we talked about Build this week. Anything top of mind that perhaps our listeners should know about?
Yeah, I think the one other thing that we released recently is some of the resource change experiences. We released a preview of that that is exposing changes to users in sort of a more first class way, and definitely encourage users to check that out and help users find what's recently changed as different outages happen. The first question users always ask is what's changed. Is there something that happened to the environment on your side? Check out some of the Copilot stuff that we've announced and give us feedback on some of the questions that you'd like to ask and things you're doing there. We're investing in those scenarios, and yeah, I'm definitely excited about where we're going in the future here with essentially being able to help customers manage their entire digital estates. We really want our customers, if they've got servers still in Config Manager, we want those servers to be connected to Arc so that they could be managed in Azure, just like they're managing the rest of Azure scenarios. We see customers leveraging Kubernetes on the edge and in their branch offices or warehouses or different sort of store locations. We'd love to see those connected into ARMS so that really we give customers a great set of capabilities to manage across that entire digital estate. So it's secured, so it can be consistently exposed in different scopes. You can leverage management groups to sort of group scenarios, and you can leverage different
and all that
policies to govern these resources. So yeah, we definitely feel strongly about some of the capabilities that we're building for customers to really reimagine how they're managing their entire digital estates. And yeah, thank you for the time, and looking forward to coming on maybe a future show.
Absolutely. Thanks again.